In this video, we're going to talk about calculating conditional probability. So before you start this video, you're going to want to be comfortable calculating probabilities that are non-conditional. So you can watch the previous video or just do some research about how to calculate probability. So the way that we're going to calculate conditional probability is we're going to look at the probability of an event occurring when we already know that another event has occurred. Okay. So for example, if I want the probability of lung cancer, this little vertical bar right here means given. Okay, so what's the probability of someone having lung cancer given that the person smokes? Okay, so what we're going to do is we're going to look at just the people that smoke and then figure out, okay, how many of those people have lung cancer? What's the chance of someone in that group having lung cancer? So the formula for this is, if we're trying to find the probability of an event A occurring given that event B has already occurred, it is going to be a fraction, and the numerator of your fraction is the probability of A intersect B, which means where's the overlap between A and B. And then you're going to divide that by the probability of being in group B. So basically you're looking at the total number of individuals in the overlap between A and B, right here, and then divide that by the total number of individuals in group B. So let's do an example. So let's say an ice cream shop keeps track of whether people order vanilla or chocolate ice cream and whether they order a sugar cone or a waffle cone. So we're going to start by filling in the marginal totals of this two-way table, and then we're going to go ahead and answer some probability questions. And in these questions, we are going to be giving our answers as simplified fractions. So if I'm just going to go ahead and total each of the rows. So the vanilla row has a total of 61. The chocolate row has a total of 98. The sugar cone column has a total of 86. And the waffle cone column has a total of 73. Which means that the total number of people's orders that I tracked was 159 people. Okay, so I kept track of 159 people's orders throughout the day, and this is the data that I gathered. So before we jump into conditional probabilities, let's just calculate a few basic probabilities based on this table. So first, what's the probability of someone choosing vanilla ice cream? So if I'm looking at vanilla ice cream, I'm looking at 61 people that ordered vanilla ice cream out of the 159 people whose orders we tracked. Okay. Same thing with the waffle cone. I'm going to look at the total number of people that ordered a waffle cone out of the 159 people that placed an order that day. So my chance of, if I chose a random person who went to that ice cream shop that day, the chance of that person having ordered a waffle cone is 73 out of 159. Okay. Let's go ahead and do the sugar cones. So that's 86 people that ordered sugar cones out of 159 orders. And then 98 people that ordered chocolate ice cream out of the 159 people that placed an order. Okay. All right, let's go ahead and do a couple examples with looking at intersections and unions. So in example E, I want the probability of vanilla intersection with sugar. So I want to know how many people ordered vanilla ice cream and a sugar cone. So I'm just looking at that overlap between the vanilla and the sugar categories. So that's going to be just the 35 people that ordered vanilla ice cream and a sugar cone. And that's still out of my total 159. If I'm looking at the people that ordered a vanilla with a waffle cone, the vanilla intersect waffle, it's going to be the 26 people that ordered vanilla ice cream in a waffle cone. I'm going to go ahead and hit pause in this video, fill in the next two for you. Go ahead and hit pause and then turn it back on when you have an answer and double check your answers. All right, hopefully you got 51 out of 159 and 47 over 159. Okay, let's look at a couple union questions. So in example I want to know the probability of vanilla union sugar, which means the probability of ordering vanilla ice cream or sugar cone or both. Okay, so I'm looking at anyone that's counted in the vanilla category. So there's 61 people that were in the vanilla category, right? And then I want to think, okay, is there anyone else that's not in the vanilla row that would count in this vanilla and sugar? And there are 51 people that ordered chocolate ice cream on a sugar cone. So I want to make sure I count those people. So 61 plus 51 is going to be 112. That's the total number of people that ordered vanilla ice cream or sugar cone or both. So my probability is 112 over 159. All right. Similar thing with the waffle cone. I'm going to look at everyone that ordered vanilla ice cream. So first thing I'm doing is I'm just totaling how many people count in this category of vanilla union waffle. So I've got all the vanilla people that ordered vanilla ice cream. And then I've got to look at my waffle cone category and say, well, there's 47 people that also ordered a waffle cone. They just didn't get vanilla ice cream, but I still want to count them here. So that means there's 108 people that ordered vanilla ice cream on a waffle cone. So that's 108 out of the 159 orders that were placed that day. Okay, I'll hit pause, fill in the last two, and then you can check your answers. All right, hopefully you got these two fractions as your answer. Okay, now it's time to look at some conditional probabilities. Okay, I'm going to go ahead and zoom out so we can make sure we see the table and the question at the same time here. So in example M, what I'm asking is the probability of someone ordering vanilla given that they've already ordered a sugar cone. So basically I want to know, if I look at just the people that ordered a sugar cone, and if I'm choosing from just the sugar cone people, what's the chance that I choose someone who ordered vanilla ice cream? So now the denominator of my fraction is no longer going to be everyone that placed an order. It's just going to be everyone that ordered a sugar cone. And of those 86 that ordered sugar cones, there were 35 that ordered vanilla ice cream. So there's 35 vanilla ice cream on sugar cone orders out of the 86 sugar cone orders. Okay. So let's look at the next one. So the probability of vanilla given that a waffle cone has been ordered. So here I'm looking at all my waffle cone orders. So of the 73 waffle cone orders, how many of those had vanilla ice cream on them? That would be 26. So the way I interpret that is that if I chose a random person, if I grouped everyone together that ordered a waffle cone, and then I chose a random person from that group, there's a 26 out of 73 probability that I chose a person that ordered vanilla ice cream. All right, let's go ahead and do the next couple. What's the probability of ordering chocolate given that you ordered a sugar cone? So ordering chocolate, let's see, the total, well, first you want to look at everyone that ordered a sugar cone. So the total number of people with the sugar cone would be 86. And then the number of people that ordered chocolate in a sugar cone was 51. And then a similar question, probability of getting chocolate given that you've ordered a waffle cone. That one we're going to look at the total number of waffle cones, so 73, and the total number of chocolates in the waffle cone category, so 47. Okay, in all the examples we just did, we were looking at ice cream flavors given a certain cone. So let's go ahead and do it the other way and look at what's the probability of ordering a sugar cone given that you've ordered a vanilla ice cream. Okay, and this is kind of going to feel similar to what we just barely did. So I'm going to look at the total number of people that ordered vanilla ice cream. So that's 61. And of the 61 that ordered vanilla ice cream, how many ordered a sugar cone? 35. And then you could do a similar thing to fill in the rest of these probabilities. I'm going to go ahead and fill them in, go ahead and press pause, and then turn it back on when you filled yours in as well. Okay, so hopefully you got those three fractions as your three answers for this one. So conditional probabilities just allow us to answer a few more questions that maybe are interesting to us, right? Maybe we don't just care how many people ordered vanilla, but how many people are ordering vanilla in a sugar cone? Or given that they're doing a sugar cone, how many people are ordering vanilla? So let's go ahead and look at maybe something that might be a little more interesting to some of you. So we're going to use this Venn diagram down here, and we're going to express our answers as decimals rounded to the nearest thousandth, which means we're going to go 3 decimal places out. So here we're looking at high school seniors and the relationship between if they're male or female and if they have an after-school job or if they don't. Okay, so in our Venn diagram, we've got a male circle. So anyone that's not included in that male circle is going to be female. And then we have an after-school job circle. Anyone not included in that circle means that they do not have an after-school job. So, first one, what's the probability of having a job given that you're male? Okay, so the first thing we want to do is figure out how many males we have in our study, right? So if you look at the male circle, that's going to include the people that are just in the male circle as well as the people that are in the overlap between male and after-school job. That's going to be a total of 48 males that were studied. And then I want to know, given those 48 males, how many of them had a job? And that's just going to be the 27 that are in the overlap between male and after-school job. So it'll be 27 on the top. So if I use my calculator to get a decimal for that, and I round it to the nearest thousandth, I'm going to get 0.563. So let's go ahead and look at another one. I'm going to erase this blue. Let's actually switch colors too so that we can use this to differentiate what we're notating on the Venn diagram. So what's the probability of being female given that you have a job? So first let's look at our total. So our total is going to be how many people have jobs. So I'm just going to look at the after-school jobs circle and look at how many total kids have an after-school job. 27 plus 33 is 60. And now of those 60 kids that have a job, how many of them are female? And that's going to be everyone that's not in the male circle. So that's going to be 33. And that is going to be 0.55. So that means that the probability of being female given that you have a job is 0.55. Let's do a couple more so you guys can get more practice using these Venn diagrams. Okay, let's use green now. So in example C, I want to know the probability of being male given that you don't have a job. So here, my total on the bottom is going to be the people that don't have jobs. So I'm looking at the people that are not in the after-school job circle, which means I'm looking at the 21 and the 19. That group of people that are not in the after-school job category. So 21 plus 19, that is going to be 40. Okay, so of those 40 people that don't have a job, how many of them are male? And that's 21. We're just looking at the 21 that are in the male circle. Then I'm going to use my calculator to go ahead and calculate that decimal. It's 0.525. So you can go ahead and work out example D as well using this same method that we just talked about. So just know, one of the most important things to know as you start calculating probability is you need to think about and recognize, is this a conditional probability statement or is it just a regular straight probability statement? So like in example E, in question E it says, a student from the sample works at McTaco. What is the probability that the student is male? Right, so then we're looking at a student that has an after-school job, and then we want to know what's the probability that he's male. So here it's conditional because the student that we're looking at, we know he works. We know he's in the after-school job category. Okay. So you want to make sure that you know if you're calculating conditional or just regular probability. That's probably your first question you want to ask when you're answering probability questions.